Imagine gazing into a mirror, not one that reflects your face, but one that reflects time itself. Not just light bouncing back, but a glimpse into the very dawn of existence, when the universe was just drawing its first breath. That, in essence, is what the James Webb Space Telescope was designed to do. But what it revealed when it looked farther than anything ever had before wasn't the serene cradle of the cosmos. It wasn't the soft glow of creation's infancy. What it found defied everything. It was a contradiction, a cosmic impossibility. For decades, astronomers believed they had a fairly complete understanding of how the universe evolved. First came the Big Bang, followed by a long period of darkness. Then slowly, stars ignited, galaxies formed, and life eventually emerged. According to this model, the further back you look, the simpler things should be: elementary particles, thin hydrogen clouds, chaotic and unshaped space. But when Webb turned its golden mirrors toward a seemingly empty, quiet patch of sky, an area expected to be little more than ancient darkness, it captured something that shouldn't have been there at all. A fully developed galaxy. This wasn't a faint, formless blob of gas. It was a structured, rotating system of stars with clearly defined spiral arms and a colossal black hole at its center. It wasn't just existing, it was thriving. And this wasn't a one-off anomaly. As data began to pour in, more such galaxies emerged from the primordial shadows. These galaxies were structurally complete, chemically mature, and gravitationally stable. It appeared as if the cosmic clock had skipped ahead, bypassing billions of years of gradual evolution to land at an era of inexplicable maturity. With each new discovery, a haunting question grew louder among scientists. What if everything we thought we knew about the beginning is wrong? When the James Webb Telescope captured an image of one of these galaxies sitting over 13 billion light-years away, it was expected to be a dim smear of ancient light. Instead, what appeared was architectural sophistication. Spiral arms coiled like ribbons of starlight, dense clusters of stars orbited in perfect harmony, and at its center pulsed an energetic core. This galaxy wasn't in the process of forming. It was already formed, and not marginally, but fully, resembling systems we would expect to see billions of years after the Big Bang, not just a few 100 million. To grasp how perplexing this is, you have to understand how galaxies are thought to evolve. In the early universe, matter was sparsely distributed. Gravity slowly pulled it together into clouds, which collapsed into the first stars. These stars grouped into galaxies over enormous stretches of time. But Webb's images suggest this entire sequence somehow completed extraordinarily fast. That galaxy hadn't just emerged, it had flourished. According to the laws of astrophysics as we understand them, that's impossible. It's like discovering a towering ancient redwood tree in freshly tilled soil. Even more confounding was the realization that this wasn't an isolated phenomenon. Across different parts of the sky, Webb uncovered numerous galaxies showing organization, complexity, and maturity that should not have been possible. The telescope itself wasn't malfunctioning, its instruments were functioning perfectly. What wasn't working was our theoretical framework, and then came the next wave of shock. When astronomers analyzed the spectral data, the light signatures that reveal the chemical composition of these galaxies, they found elements that shouldn't yet exist. Oxygen, carbon, even iron. These elements don't simply appear there. Created in the hearts of massive stars and dispersed across the cosmos through supernova explosions. This cycle from the birth of first-generation stars known as population 3 stars, to their deaths, to the formation of new, enriched stars was believed to take hundreds of millions, if not billions, of years. Yet here they were, galaxies under 400 million years old, containing elements that required multiple stellar generations to exist. That means stars had not only formed and died, but had done so repeatedly. The early universe wasn't slowly awakening. It was sprinting, igniting, burning, collapsing, and reforming in a frenzy no one had anticipated. These elements aren't just the byproducts of stars. They're the raw materials of planets, atmospheres, and potentially life. Finding them So early is like stumbling upon a thriving coral reef beside a volcano that erupted only yesterday. The timelines weren't just compressed, they seemed shattered. And just when things couldn't get stranger, astronomers peered deeper into one of these ancient galaxies and found the most astonishing feature yet, a supermassive black hole at its core, weighing over 1 billion times more than our sun. In the current universe, that would be impressive. In the early universe, it's cosmologically outrageous. Black holes are believed to form from the remnants of massive stars and grow gradually, consuming surrounding matter over billions of years. Even the most optimistic models, with ideal feeding conditions, cannot explain the existence of such a massive black hole so soon after the Big Bang. It would be like discovering a fully grown adult who was born an hour ago. The math simply doesn't work, and yet the evidence was undeniable: the gravitational pull, the rotation of nearby stars, the energetic emissions, the warped space. It all confirmed the presence of a black hole that hadn't grown, it had appeared. Now, scientists are being forced to consider radical new theories. Some propose that black holes could have formed directly from extremely dense regions of the early universe, primordial black holes. Others speculate that exotic particles or dark matter may have accelerated their growth, but these aren't tweaks to existing ideas, they're new blueprints for reality itself. What do you do when observation contradicts every rule you've learned? For many cosmologists, the answer is unsettling. You rewrite the rules, because Webb didn't just show us outliers, it exposed a universe behaving in reverse. Complexity arriving before simplicity, ancient light revealing structures that shouldn't yet exist. Some researchers now suggest that dark matter, once thought to be passive, might have actively shaped the early universe, acting like a cosmic scaffold that enabled galaxies to form faster. Others propose that time itself may have flowed differently in those early moments, stretched and warped in ways beyond our current understanding, allowing entire epochs to pass in what now seem like mere instants. And then there's the most provocative theory of all, that maybe the early universe wasn't different from ours. Maybe complexity wasn't the destination. Maybe it was the starting point. As Webb's observations continued, researchers began noticing something even stranger, something not related to size or brightness, but to shape. Using advanced learning algorithms, they found that the distribution of these early galaxies followed a specific repeating mathematical pattern. It resembled the golden spiral, a structure found throughout nature, art, and biology. This wasn't just visual beauty, it was structural geometry and elegant alignment spanning billions of light years. The layout of matter followed a fractal pattern, suggesting the universe might have been coded from the beginning with a design echoed across every scale. Not random, not chaotic, but organized. The spiral arms, the rotational symmetry, the orbital precision all indicated a deeper pattern, but a pattern of what? A new law of physics yet to be discovered, or something more unsettling, a suggestion of intention woven into the very structure of space and time. One of the most controversial discoveries didn't come from a star or a galaxy, but from an apparently empty region of space, a void so ancient and vast it was assumed to be sterile. Yet Webb's instruments detected something extraordinary: complex organic molecules drifting freely. Not basic compounds like methane or ammonia, but polycyclic aromatic hydrocarbons, molecular precursors to amino acids, the building blocks of life. These weren't found on planets. They weren't nestled inside stars. They were just floating, ancient, unbound, and somehow intact after nearly 13 billion years. The implications were staggering. Life's ingredients hadn't formed later in the safety of maturing solar systems. They had been present from the very beginning. If true, this suggests that life isn't a cosmic accident. It's a built-in feature of the universe itself. Then came the image that silenced even the most skeptical minds. Within a cluster of high redshift galaxies, Webb captured a formation too perfect to ignore. 6 galaxies arranged like petals around a central point, spaced at equal distances, rotating in synchronized orbits. Astronomers called it the flower. Despite attempts to dismiss it as coincidence or gravitational lensing, No natural model could recreate its symmetry. It looked like choreography, frozen in light, from a time before Earth even existed. Some tried to explain it through quantum turbulence or residual symmetries from the Big Bang, but others quietly wondered, what if this wasn't nature? What if it was a message, a signpost, a marker left behind, waiting to be seen by a civilization advanced enough to recognize it? And finally, the most chilling possibility of all emerged, not about what we observed, but what might be observing us. In quantum mechanics, there's a phenomenon known as the observer effect, where simply measuring a system can alter its outcome. What if that principle doesn't stop at particles? What if the universe, at some unimaginable level, is responsive to attention that by building Webb and turning it toward the earliest chapters of the cosmos, we didn't just witness something, we activated it?